I know you guys have been asking for new FPV drone build video for a very long time, and I have been putting it on shelf for variety of reasons. First of all, I already have 4 to 5 different drones in my fleet, so I was not looking for a new drone to add it to my fleet. And the second reason is I am not sponsored by anyone. No one is sending me free parts or drone frames so I can make a new video for you guys. But recently something happened. I actually crashed one of my favorite drone of all time. I made an Impulse RC Apex 5 dead cat frame last year and I crashed it recently. It caught fire. So I was looking for a new frame, and I think this is the best opportunity to build a new drone frame. But the thing is, a lot of you community members are asking for a budget drone build video. Now I want to make one thing very clear, that budget can be different for different people. And I have said this various times that FPV drone build hobby unfortunately is not a budget hobby. You cannot enter it with 10-15,000 rupees. You might be able to make a drone in that much amount, but that will be a shit crap drone that will not give you a good experience. You will crash, you will break it, and then you will end up spending more money. So I always recommend everyone who wants to get into FPV to have a good budget. At least have 1.25 lakhs initially to start to build a great radio, great transmitter, goggles, and then build a great drone. So budget can definitely mean different for different people. And if you talk about me, I usually put 40 to 50,000 in one drone because this drone is also my business. I go out and I take them on gigs. I make money with it. So I want the best quality part possible. I don't want this drone to fail me when I'm making videos for clients and doing some things outside the country. I want my drone to be rock solid. But a lot of things have changed recently and I'm giving myself a challenge today. So the challenge that I'm giving myself is to build a new FPV drone under 25,000 rupees. And I think it's quite possible for a couple of reasons. So recently, a lot of parts have been started to come into India, and a lot of the things that you are seeing are all available in India in FPV drones. Initially, I have to import it, better frame, better motor. You just have to go to China or US and import it. But recently, a lot of new FPV hobby stores have coming up, and these parts are very easily available. So I'm taking a challenge on myself for this video, and that is to build a new FPV 5-inch drone under 25,000 rupees. I think I can do it. I think we all can do it together. So what I'm gonna do, I'm gonna select all the parts, I'm gonna order it, and then we'll move towards the build, and I'll show you everything that you will need to build your first 5-inch FPV drone. And this is the best opportunity to get into the drone hobby and learn from me. I'm gonna share every hack that I have learned over the last 8 to 10 years of building FPV drones. So let's get this video started, and hopefully together we can win this challenge. So the thing is that I already am using GoPro Mach5 frame for all my fleets. Let me show you. So this is the frame that I am using for a very long time, and I have always recommended everyone that if you are even building a new drone build, then make sure all the parts are same. Only then you can get the best flight experience, a consistent flight experience. And the thing is, this frame also comes in a dead cat version. This is currently like a stressed X version, and I want dead cat version, but it's out of stock everywhere. No one is able to get it for me. Someone has recommended a different frame, but I'm not very sure. I wanted to you continue using this frame, even though I don't really like GoPro as a company. I don't have a great experience with them, but I'm flying it for a very long time, and this frame was great frame to build, and it flies great. And yeah, the same version is available, but I want dead cat because in dead cat frame the propeller doesn't come into the picture. So I'll keep trying and see if I can find it anywhere else in a different shop, or I have to import it. Otherwise, I got a good recommendation and I really trust that guy for recommendation. So I'm gonna check some reviews of that frame, and if I cannot find the GoPro Mach5, then I will order that frame. Alright, so I have ordered all the parts. Now let's wait for the parts to arrive and then we'll start the build.
2 weeks later.
Alright, so I got all the parts that is required for this specific drone build. Let me unbox it and share it one by one why I chose this specific part, and agar koi alternative hai to I'll also suggest that. So let's start with the drone frame, and this is something that you have already seen on this channel. So this is the AxisFlying Manta5 dead cat version, and jo ye frame hai, iska assembly and unboxing is already available on my channel. You can check out the video, link will be in the description. So talking about the next thing, let's check out the motor. So the motor jo maine li hai for this particular build is by Tmotor Velox 3.0. So this is is going to be a Tmotor build, and Tmotor is a company that I am trusting for a very, very long time. I am using their products in almost all my drones, and they are very high quality parts. So the motor that is a Tmotor Velox V3.0, and the specification of this motor is 2306. 1750 kV. I'm gonna be using with a 6S battery, so that is why 1750 kV. So let's quickly check out one of the motors. So this is the Velox V3 2306, and I love the color. It comes in purple, which is also my brand color. That's why I'm using this motor. So 1750 kV, great design, great build. Winding is superb. Bearing is really, really smooth. Let's check out the actual flight stack. So that's also from Tmotor, and this is not as expensive as you might think, because this is the SE edition of Tmotor Velox. So talking about the flight controller, it's F7. It has a Bluetooth configuration available, so you can use your SpeedEV application. So currently I'm building an analog drone, but even in the future, if you want to upgrade it to HD using DJI-O3 or whatnot, it's still supported. A really great flight controller will have all the features, so we'll check it out in a bit. And isko साथ में run करने के लिए we are having Velox 50 amp 4-in-1 ESC. They were great together, and this is again an SE edition, so it's not that expensive. One thing that I really like to stress here is if you are a beginner pilot, then try to stick with only one company and only recommended parts by that company. इसीलिए मैंने यहाँ पे choose किया है Tmotors की motor, Tmotor की flight controller, Tmotor की ESC, because this propulsion system will work really great together. Alright, moving towards the next part, let's talk about the video components. So the camera that I'm gonna be using, it's analog cam CaddxFPV Rattle. I've already used it before in some other builds, so it's a great little camera. So this one comes in black, and you can see it's a CaddxFPV analog camera. Nothing more to say about it, but yeah, it's a beast, and I totally trust this camera. And to pair it with the video transmitter, I'm gonna be using this long range video transmitter. It's a really great. It's by HGLRC, and the model number is called Zeus. I think it's around 1200 milliwatt or something like that, or 1 watt. I'm not very sure, but yeah, you can easily use it for long range missions. And this VTX I already had from one of my previous builds, so ye maine naya nahi kharida. I'm gonna be reusing it. It's fine, and look at this, such a small form factor, and it's a long range VTX, so you can definitely fly long range. Talking about long range, we have a GPS here. So recently I've started putting GPS in all my quads, because definitely quads are really expensive to build and you don't want to lose it. So with GPS, you can activate return to home in any case your quad goes lost, or you can also check coordinates where it's crashed and things like that. So it's by the same company, Rush FPV, and I really trust Rush FPV products. And it's an M10 GPS. That means it will get satellite locked very quickly. And yeah, you can see it's a very small form factor, and what more to say, I've already soldered it. So yeah, I'm gonna be using this GPS. And talking about transmissions, the receiver I'm using, this is my first time using this receiver, but this is a ExpressLRS true diversity receiver by iFlight. So you can see there are diversity receiver and there are true diversity receiver. So these actually is a true diversity receiver. That means it has individual antenna and receiver connections. So this is ExpressLRS by iFlight. Also, I already soldered these wires, and this has two antennas. I wish this antenna wire is longer, at least one of them, so I can put one behind and one forward, but yeah, that's what you get. And I already have a video antenna that will go with my Zeus. So this one is a lollipop antenna. I don't recommend this antenna because it is not suitable for long range flight, but I'm not gonna be using it for long range for this particular time. But yeah, this is by UX2, 5.8 GHz antenna. I don't really know when I first bought it. So for now, I'm good. Later down the road, I might upgrade this quad to digital because I don't really like flying analog, but to keep everything in budget, we are going with the analog build. Last but not the least, we have propellers. So propellers is again from Tmotors. It's also recommended for this particular stack. So this propeller is a T5143S. So for 5143 means 5.1 inch and 4.3 inch of pitch. So yeah, that's the propeller and that's what we're gonna be using. So a quick review, we're gonna be using AxisFlying Manta5 dead cat frame. We're gonna be using Tmotor Velox V2306 1750 kV motors, and we will be combining it with the Tmotor Velox F7 SE propulsion system. And for the video, we're gonna be using a Zeus HGLRC long range video transmitter, combining it with a very poor antenna that I don't recommend. And for the receiver, we have iFlight 2 diversity receiver, we have a Rush FPV GPS, and we have Tmotor propellers. But that being said, जरूरी नहीं है ये सारे parts आपको easily मिल जाए, so you can definitely look for alternatives. If you want to look for any alternatives and you cannot find it, then comment in this video and I will help you find those parts. So now let's move forward and build this drone, and on the way I'll show you all the tools that you will require to build this drone, and also share all the hacks that I have learned over several years of building FPV drones. So First of all, let's start with the frame, and one tip that I want to give you right away is start from the outwards and start building inside. That means we will start with the frame, add motors, and then we'll stop going inside. So over the first thing, as you can see, I have already assembled this frame. If you want to, find the video of how to assemble this frame, you can check out my old video. And if you have a different frame, then do follow the guidelines provided by your frame manufacturer. But yeah, first let's unbox all the motors, and we will start attaching the motors on the outside. So for quadcopters, we having 4 motors, of course, and we are getting Tmotor stickers with this. So I'm just gonna put it here because I love Tmotor. Alright, so we got all the 4 motors over here, and it doesn't matter which one goes where because every motor is identical. One thing that I mentioned previously is if you look at this motor protector design of this frame, it has a 3D printed part only at the back. So over here we need bigger screws, and Tmotor provide bigger screws, and they also provide the smaller screws. So smaller screw will go in the front and bigger screw will go at the back. And I'm mentioning it because it's really important, because when you screw the motor, you have to make sure that the screw doesn't penetrate this winding, because if it does, the motor will be destroyed and your drone will be short circuited at the very first time you put the battery and arm it. So make sure whenever you are putting the screw from the arm, it shouldn't touch any motor winding. So I'm using my trusty electric screwdriver to put on the screws on the motor. So you just have to put the motor like this and just screw it from the arm below. So it's really helpful if you first put the diagonal screws and not the side-by-side one. Some people just like to put 2 diagonal screws, but I really like to put all the 4 screws. It really keeps the motor intact. You can also use some Loctite, but I'm not using it. I usually test my quad first, and later on I put a Loctite if needed. Alright, so we have attached the first motor, and I'm gonna repeat the step for all 3 motors. Alright, so all the 4 motors are attached to the frame, and I made sure that no of the screws is touching the winding, and still it has a great lock. And you can save the rest of the screws for some future build or any sort of replacement or any sort of repairing that you might be doing later at this drone. But now let's move inward. So the next step that I'm going to be doing is adding ESC, solder the XT60 wire, and then solder these motor wires to the ESC. So there are a couple of things that I like to mention here is that the way that the frame is designed is for XT60 to come out from the front like this. I don't really like the design because the GoPro hits the XT60 wire and it makes all sort of vibration. So what I really like to do is for my drone, the XT60 should come at the side, and that's what I'm going to be doing on this drone. Second thing is the ESC comes with this capacitor, and with 6S the capacitor is a must, don't leave it. So this comes with the 470 microfarad capacitor that has to be put against the positive and the negative terminal, but I'm not going to be using it. It's fine, you can use it, but I have a better capacitor, 1000 microfarad low ESI capacitor. I'm going to be using this one, but you can still use it, and you don't really notice any difference. But I like to use a low ESI capacitor. It's a bit expensive, but I have a stock, so I'm going to be using this one. The second thing is this ESC is a 4-in-1, and it connects with the flight controller using a single wire. But because I am an idiot, I actually pushed it so hard that the flight controller port breaks off, and that's why I'm not gonna be using this, because my flight controller ESC port breaks off because I have pushed it too hard when I was testing it when I first unboxed it. So what I'm gonna be using instead, on the flight controller it also has motor pads like this, so I'm gonna be using this one and solder directly the ESC motor wires over here. So let's first start by putting the ESC over here and solder the XT60 connector. So the ESC will fit like this, and the XT60 will solder over here. Make sure that you are soldering it right, because over here you might get confused and it's mentioned it's a positive, it's a negative. So the right side of the XT60 should go into the positive and the black side should go into the negative. So we have to make that sure. And for that we need soldering iron, and this is the soldering iron that I use. This is the Sequoia portable soldering iron. So I'm gonna be putting this to 450 degrees Celsius because it takes a lot of heat to put XT60 connector over here. The other thing that you can use is a liquid flux that makes the job a bit easier. If you cannot find liquid flux, you can also use this solder flux that is very easily available. And yeah, keep your soldering iron tip clean. You can use this sort of a wire gauge, and you can use this sponge to clean drop. So let me first apply some flux over here into the connector, and I'm going to be using liquid flux like this, and this will make sure that the soldering becomes really easy. And I'm going to be using my solder. I have to melt a lot of solder over here, so that's my solder. It becomes really easy if you haven't put these pillars first. These standoffs comes really into the way, but nevertheless we're gonna be doing it anyway. So one pad is soldered. It should be shiny solder as you can see over here. Alright, so we have successfully soldered these pads and now we have to measure the XT60 length and cut it like this so it comes up the side. So I'm gonna take a rough ballpark and cut it like this so it comes out like this. And this is where I will be cutting it here. Let's use some flux beforehand. It becomes really easy if you have this. This is like blue tack screw, and you can just attach your wires here like this and then tin it. Now it's time to attach it to the ESC itself, and for that it's really handy if you have something to hold this because this wire can get really hot. So just double checking that we are attaching it at the right place. Just like this, melt the solder. And the XT60 is attached and it can easily come off like this from the side, and it can also come at this side, so whatever side you suit you can put it there. So I'm probably gonna be using it over here. I'm later gonna add a zip tile over here. Now for the next step, we need to tin all these wires, measure the motor wires and connect them here with the help of solder. And for that I'm first gonna tin these wires and then I'm gonna measure and cut these wires and we'll solder them together. So same process, let's first add some liquid flux to all this pad. At this point it doesn't really matter which of the motor wire will go at which pad. You can always change that in the software, so we're gonna handle that later on. But for now let's add solder to each of the ESC pad. And you don't have to put a lot of solder here, you just have to make sure that these pads are tinned. So these pads are tinned. Now for the next step, what I'm gonna be doing, I'm gonna be measuring the wire from the motors and I'm gonna be adding it over here. Leave some slack for future because you might want to, come back and repair it at any point. So we should always have some slack in the wires. Alright, so we have tinned all the wires and now we're going to be attaching them to the ESC. So the order at which you solder these wires to the ESC will decide if the motor will spin clockwise or anti-clockwise. And traditionally, if you want to change the ESC motor direction, because that is really important for drone, you just have to take two wires and swap their connection with the ESC. But in modern times, we can handle that in the software, so we are not going to be worrying it. And we attach wires in any order that we see feasible. Just make sure that the pads are not shorted. Each pad should have its own individual wire and it shouldn't be shorted to the next pad because that can be catastrophic. Alright, so we have soldered all the wires to the ESC. I'm just gonna do a quick inspection to make sure that there are not any shorts and the solder is not flowing to any nearby MOSFET, and everything looks good from the top. So we can move to the next step, and that is adding the capacitor. So this frame comes with this capacitor 3D printed mount that I'm going to be using. So just need to make sure that the capacitor wires are good. So this is the positive and this is the negative terminal. So it should go like this. And this is where the capacitor will be held using the 3D printed mount. Just need to make sure that the capacitor wires are not shorted because these are directly connected to the battery. And if capacitor wire is shorted, that means the battery is shorted, which is not good when it comes to lithium polymer batteries. So that is soldered, and then we're gonna cut off the excess lead so it doesn't short anything else. Yeah, you really need to make sure that nothing is shorting when it comes to drone because that's where the trouble starts. And now I think everything is looking good, so we can start putting the flight controller and camera and VTX together. But before that, I just would like to give it one quick checks to make sure that it's not shorting the positive and negative terminal, and for that I'm going to be using the multimeter. So the way to use multimeter is to put into the continuity test, that is this particular thing, and what that means, if there is any short, then it will beep like this. So I'm just going to put it against positive and negative terminal, and no, there is no short, so we should be good. And it's also good to check this time to time before putting any battery. So once we have made sure that it's not shorted, then we can put a battery and check if everything is looking good. If everything is good, then you will hear a good beep sound, and if it's not, then you will see great white smoke coming out of this drone. So let's hope for the best, and no one wants to see a smoke today. We are good. So that was a good test and everything is working fine. We will come back and sort the ESC wires later on, but now let's go ahead and put our flight controller. So for the flight controller, as I mentioned, I had been an idiot and I actually destroyed the ESC connector. But for the flight controller, you just have to make sure a couple of things. First thing is that make sure that this arrow is pointed forward. If for some reason you have to mount it otherwise, then you have to change it in the software. But for me, it's not the case. So I'm just going to mount it directly on top of the ESC. The second thing that you want to check is when you mount your flight controller, make sure no metal thing is coming in contact with the ESC. That could short your motors or ESC. So I'm just gonna give a small inspection from each side and it looks good. Nothing metal is touching anything on the flight controller, so we should be good in this case. And before that, I just need to make sure that I'm doing the right connection. So what I'm gonna do, I'm just gonna bring out the flight controller and use this wire supplied with the ESC to solder directly over here. This flight controller can handle 8 motors, so you can make octacopter or X8, but I'm just gonna be using 4 motors over here at the moment. I think all the connections are now done, and if everything is right, the flight controller should get powered when we power the ESC. But first, let's secure this connection. So I'm just gonna roll these wires like this. So as I mentioned, I'm just doing it because I destroyed this connector. Otherwise, it would be a very straight situation. But that's okay. Mistakes are okay to be made while you are building such drones. So now when we power the drone, ideally the flight controller should light up. So let's give it a quick test and hope we don't see any magic smoke. There we go. So now you can see our flight controller is powered. So that means the power is transmitting from the ESC to the flight controller. So everything is looking good. Now we're gonna be screwing down this flight controller and we're gonna be using these nylon nuts. What's really important is to make sure that the flight controller is not touching the ESC directly. And that usually don't happen, especially if you're buying same company's flight controller and ESC stack. But if you're having a different company, then definitely make sure that there are enough gap between the ESC and flight controller. Alright, so we have mounted flight controller and ESC on the silicon grommets and then we have tightened it over here. I think the next logical step would be to put these motor wires down and tape it here. So to attach the motor wires, I'm using this tape. This is, I think, a fiber tape. It's available on Amazon. You can order it. This one is really great. So first of all, let's make sure that we have a clean and tidy wire going from motor . Alright, the motors are all taped down and now we can attach camera, VTX, GPS and all the things. But before that, I have these 3 LED wires coming up over here. So I'm just gonna attach the LEDs very quickly. And we need 5 volt, ground and LED. So what I'm gonna do, I'm gonna add the wiring diagram of this flight controller on the screen so you can follow it if you have the same flight controller. And if you have a different flight controller, you can just check the wiring diagram on the manufacturer website. It will show everything where each component will go. So when you become an experienced drone pilot, you understand how to route the wires effectively to have the least possible wire usage, and it comes with experience. You will not be able to achieve it from the day one, and that's totally okay. But once you keep building your drone, you will get an idea of how to best route your wires. And that's why you can see that even before attaching anything, I have my LED wires coming from the side because I know that this particular flight controller has pads for the LEDs on the left side. Done. So we have soldered the LED wires. Now let's add let's add GPS and then we can add VTX and camera. And the reason I'm first attaching GPS and not VTX is again experience, because the GPS wires will be coming over here from the down and over here will be putting VTX. So it's good if I first check the wires of the GPS and then attach VTX on top of it. So as I mentioned, I already attached wires to the GPS. So GPS pins are over here. So first of all, let me quickly tin all the pins, again using some liquid flux. So these are all the GPS pins. For the GPS, I'm going to be using 5 volt to power the GPS ground, and then we will be using a UART, it's R5 and T5, and then we have SDA and SCL, so these are I2C wires for the GPS compass. Okay, in terms of GPS, always remember that the antenna should face up, so this is written over here towards sky. So I'm gonna be putting my GPS in this 3D printed mount, which has been provided by the frame itself. But if your frame doesn't come with the GPS 3D printed mount, you can design and print it yourself. So my GPS is soldered. Now let's put the analog camera. So the camera I'm using, I already showed, is this CaddxFPV Rattle2, and I'm gonna be using the wire that comes with the camera itself. Okay, so my camera is attached, and now we can solder the camera. So this flight controller has one power pad where you can select how much power you want to give to your camera. So this camera can easily handle 6 cell battery voltage, but I'm still going to be using 5 volt. So I have to, jump this jumper over here to make sure that 5 volt is going out of this camera connector. And then I'm going to measure how much wire I need. I just going to leave some slack, and then I'm going to solder over here. So there are a few things that we need to solder over here. The first thing is the camera power. Then we have the ground, and then we have the camera signal. Alright, so the camera wire is attached, and now we can move to the VTX. Similarly to the camera, you can select whether you want the VTX to have 5 volt or 10 volt. I will have my VTX to have 10 volt because that will give me the VTX the maximum power it required. Not the maximum power, this VTX can take a lot, but I would always go with 10 volt when it comes to the VTX, or even more. For the VTX, we're going to be using 4 wires. One is power, one is ground. Then we have video output signal that will come from this here, and then will be fed into the VTX. And then the VTX will be receiving signal from the flight controller, how much power it should radiate. And for that, it should be having the transmitter, that UART of flight controller, going into the receiver of the VTX. So we all going to be soldering in here. I'm going to solder everything, and as I mentioned, just follow the wiring diagram provided by the flight controller manufacturer, and you should be good to go. Alright, so we have soldered the connection to the VTX to the flight controller, and now to mount this VTX, there are a couple of ways. One thing is you can screw down directly over here. It has the built-in drivers, but I'm not gonna screw it down over here. Instead, I'm just gonna use double tape to paste it down there. Never ever power your VTX without an antenna, that will destroy it. So I'm not gonna power it without an antenna, but if I put it down here, it should be a very solid fix. And then what I'm gonna do, I'm gonna attach the antenna to the VTX. For added security, you can also add a zip tie to the VTX along with the frame, which I'm gonna be doing as well. Alright, so we have put up the VTX, camera, GPS, motors, ESC, flight control, everything. The last thing that's remaining is the receiver. Receiver is the device that will receive signal from our remote control, and we can control the drone from this. And to add the receiver, we're gonna be using another UART because receiver works on UART, and we have 4 wires with the receiver. We have 5 volt, ground, TX and RX. 5 volt will go to 5 volt, ground will go to ground, RX of receiver will go to TX of flight controller, and TX of receiver will go to RX of flight controller. So for the receiver, we have a dedicated wire at the back, and that's what I'm gonna be using it. Quite straightforward. The only decision that I need to make now is whether I need to mount my receiver at the back or at the front. I think I'm gonna go and put my receiver at the back, because at the back we also have a receiver antenna holder. But that's totally up to you. In GeoRC Mach5, I like to put receiver in the front because that gives even better wire routing in that particular frame. But I think for this particular frame, I like to put it at the back. Alright, so we have connected our receiver. Before putting it to the place, I'm gonna give a final power test to everything and make sure that every component is coming up. So when we apply the power, we can see the receiver is lighting up, the VTX is lighting up, and also the GPS is lighting up, so we are all good. Now let's put the receiver in place using another double-side form tape, and then we're gonna zip it all together. So I'm just gonna put my receiver on the top of VTX. Frequency-wise, they are very far apart. Receiver is 2.4 gigahertz and VTX is 5.8 gigahertz. So I'm not worried about any interference happening. And I've done it a lot of times, so I don't feel underconfident doing this. So one of the receiver antenna can come from the back, and my receiver can sit over here like this. and this is where the receiver wire, the antenna wire can sit. I think this was made specifically for it. I'm not very sure, but yeah, it's secured. It's pretty much secured. And one of the antenna I can mount it on the arm, and the remaining wire I can tuck it down there. So this antenna wire, I am more comfortable at taking it as far front as possible and then mounting it like this using a zip tie. So we need a couple of zip ties to clean it up, one for the VTX and receiver and one for this specific antenna. So one zip tie can hold together receiver and VTX to the frame. We don't have to super tight it. And then I can have two zip ties holding the second antenna, and my receiver antennas are secured, one at the back and one at this arm. Alright, so everything is done now. Now let's clean up the desk, program the flight controller and make sure that we are receiving the video signal in our goggles, and I will be back after cleaning the desk. Alright, so we have successfully built the drone. The first thing that I like to check after building a drone is to check whether I'm receiving video signal on my goggles or not. So these are my fatshark goggles. I have attached my video receiver over here, and if I power on this drone, I should be able to see the video feed coming into my goggles. So now let's check that. And yes, indeed, I'm receiving the video feed on my goggles. So my VTX and camera are working fine. You can check that. I'm not very sure if it's gonna be visible over here, but if you can see, I'm waving my hand in front of the drone and it's reflecting on here. So now that's taken care of. Now what we can do is we can program this drone on the computer and we can move to the betaflight screen where I'm gonna show you how to program this drone. Let's go. Alright, so as you can see, the board is already detected. So I'm just gonna connect it and I'm gonna see how everything looks. So if you have installed everything right, then the board should imitate this, and let's quickly calibrate the accelerometer and you would be able to see that the drone is moving in the direction that you are moving the drone. So you can see everything is looking good in the screen. But first, what we really want to do is we want to update the firmware on this board. So what I'm going to do, I'm going to disconnect this wire. I'm going to press the reset button over here. Then I'm going to attach the wire again, and then I'm going to go to the firmware flasher stat. The build is complete. I'm now gonna click on flash firmware and it's gonna flash this flight controller with the latest firmware of the betaflight. I'm using betaflight. If you want to use any other firmware, then you can use that as well. So it says programming successful, and then I can click on connect. I'm not gonna run you through all the things that betaflight offers. It's gonna take a lot of time and efforts, but you can watch certain people videos. I'm gonna link in the description below, like Joshua Bardwell and some other folks. So you can use their videos and their content and you can understand how betaflight works. All right, so we have tested and everything is working perfectly. I'm gonna continuing programming this drone later on, but first finish the drone build and let's go for a quick test flight. So for that, we just need to add the top plate like this and just screw it down using the screw provided in the kit itself. So for the front, we also gonna be adding the GoPro mount. So I have attached it like this. Let's put the GoPro mount in the front. Right, so the frame is now completely assembled and this looks like a really beautiful frame, and I'm admiring this frame a lot. We're gonna be using the battery straps that comes with this frame to mount the battery, and let's take it to a quick test flight. One quick tip over here is if you are mounting battery strap, then make sure that they are alternate. For example, the strap 1 should be the buckle coming from here and the strap 2 should be the buckle coming from the other side. That's gonna hold your battery really well. I'm using the orange propellers, and you need to make sure that the propeller also goes in the right direction. So this one is the clockwise propeller, this one is the anti-clockwise one, and similarly you need to make sure that all the propellers are going to the right motor, otherwise your drone will flip as soon as you arm it. So just follow this pattern of motor direction and the propeller direction if you are unsure, and everything should be good. If you arm the drone and your quad flips, then high chances if either one of your motor is rotating in a wrong direction or you have put the propeller in the wrong direction. So if you fix that, you should be able to good to go. And also one more tip, that during the first flight, don't add any GoPro or any camera. Just make sure that the drone flies great. Once you've done everything, once you make sure that the first flight and the maiden flight is good and the drone is not behaving abruptly, then you can add the camera and then you can start PID tuning. Of course, you can follow a lot of different PID tuning guides available on the internet, on the YouTube. I'm not expert myself But I hope you learned something new and enjoyed this drone build video. I really enjoyed building this drone with you, and this is the battery that I'm gonna be using. It's Tattu Rline 1400 mAh 150C, the battery that I use for my FPV drones. Alright, so that is the drone build. Now let's take it for a quick flight and come back and discuss all the finances. Alright, so the drone flies great and I really enjoyed building this new drone. This is gonna stay in my fleet. I really love this frame. I really enjoyed flying this. The flight characteristics are amazing. I'm gonna tune this drone and probably I will be replacing every drone in my fleet with this new frame from AxisFlying. Now for the moment of truth, let's really see if we were able to fulfill the challenge and if this drone was actually built under 25,000 rupees. So let's start with the frame itself. So the frame AxisFlying Manta5 inch dead cat come for rupees 5,500. I know it's not a cheap frame, but I really wanted to build this frame. If you wanted a cheaper frame, then you can definitely go with the TBS Source one or something like that, and you will save around 1,000 to 2,000 rupees over there easily. 4 motors come for 4,200 rupees. Also a bit expensive motor, but I really like Tmotor, that's why I went with them. The stack costed me 8,500 rupees, which is not bad because it's a great Tmotor stack. The VTX I already had it myself, but if you want to buy the same VTX, it will cost you 3,800 rupees. You can definitely buy a cheaper VTX, but that will not give you a longer range. But you can still get a very decent range with 800 milliwatt VTX from AKK or TBS, and that will cost you around 1,200 1,500 rupees, so you can definitely save some money there. The receiver costed 2,800 rupees. Again, you can find cheaper receiver, but I wanted diversity receiver, that's why I went with them. And finally, the GPS costed 1,800 rupees. So the total cost of building this specific drone came out to be 29,600 rupees, and unfortunately I lost the challenge of building this drone under 25,000 rupees. Can I build this drone under 25,000 rupees? Yes, of course. If I go for a little cheaper parts, I wouldn't say that those parts are bad, but I really wanted these specific parts because I always like top tier parts, and I agree this is not the top tier drone, but still it's a very decent drone. I can take it anywhere, I can earn money with it, I can take it to the gigs for long range without any worry. But yeah, we are losing challenge by a little margin of 4,600 rupees, and that's okay. I never really thought that even building a drone in 30,000 rupees would be possible. Of course, the cost for the goggles and the transmitter would be different, but overall I would say this is a great build. You can still save some money here and there, and you can still get the drone at 25,000 rupees. But that was the drone that I wanted to build, and I hope you really enjoyed it. I hope you learned something new, and do leave a comment below if you have any problem with any part. I will definitely help you out. Follow me on Instagram if you haven't already, because I'm gonna be doing a lot of drone related giveaways very soon. There are a lot of parts that I don't use that I want to give away to you people. So thanks a lot for supporting and watching this video to the very end. I hope you really enjoyed it and learned something new. And since you are now a drone builder and a drone pilot, do check out this video where I talk about how to maintain your drone, and definitely check out this video where I have shared mistakes that every drone pilot makes and how you can avoid them. So that was all in this video, and on that note, I'm gonna see you in the next one.